Hello and welcome to the Consilium Aquis Sulis Introduction to Requirements Management, part of our series on Introduction of New Technology. This course is intended for anyone interested in ensuring products and services meet customer and regulatory requirements. It consists of a single online video presentation which can be viewed at will. Please note that the course is for educational purposes only. Please consult the standards and legislative requirements applicable to your specific industry and country for definitive information. There are no prerequisites for attending this course. This video will begin with the question, what is the problem we are trying to solve? It will then describe how to define system boundaries and architectures and how to break down requirements. Finally, it will explain how to answer the question, did we do what was required? The first step in developing any product or service is to clarify the problem that we are trying to solve. To this end, requirements for the product or service should be identified. At this stage, it is best to avoid preconceived ideas about the solution, focusing on what is required, not how it is delivered. Each requirement should be unique, not duplicate other requirements. Atomic, not divisible into two or more separate requirements. And verifiable, so that evidence can be presented that the requirement has been met. Requirements can be written as text or expressed visually, such as in the use case below. Unified Modeling Language, UML, and Systems Modeling Language, SysML, standardize the visual representation of requirements. How a product or service is actually used may differ significantly from its intended use. Requirements should consider all reasonably foreseeable uses. For example, the intended use of a bed is for a sleepy adult to lie on it. However, it may have many more actual uses. Dinner party guests may sit on it, children may jump on it, an adult may stand on it whilst changing a light bulb. Requirements on what a product or service should do are known as functional requirements. However, they are not the only requirements. Typically, there are also many non-functional requirements pertaining to cost, environments in which the product or service can be used, safety, how long it should last, its reliability and/or availability, maintenance and spare support, etc. Products and services may be required to conform to certain standards. Each standard typically contains many requirements. Deployment in a specific market may also entail compliance with specific laws. Like standards, each applicable law may contain multiple requirements. Whilst developing requirements, it is important to clearly define the scope of the product service, the system. A system boundary delineates the points at which the system interacts with the outside world. Having set a system boundary and identified what is required, work can start on considering how those requirements will be met. There are often many ways to address requirements, so it is important to identify a variety of options. The system could be a service or a product or a combination of the two. It could be something new or an adaptation of something that already exists. It may include software, data, electronics, mechanics, or other hardware. There may be human activities in the system, or it may be entirely standalone. If no viable option for addressing requirements can be found, or resources would be better used elsewhere, the option of doing nothing should always be considered. Selection of a preferred option should consider cost and resources required, benefits offered, time to develop and time to deploy, and risk that things won't go as planned. Doing nothing is always an option. Once a preferred option has been developed, a system architecture can be designed. The system will typically consist of multiple subsystems of various types: hardware, software, data, human activities, bought-in services. Each subsystem may itself have multiple components or subsystems. System-level requirements should be broken down into requirements on the various subsystems. These, in turn, should be decomposed into requirements on lower levels. Subsystem requirements should be traceable to system requirements and component requirements to subsystem requirements. Compliance with a requirement at one level can thus be demonstrated from compliance with requirements at the level below. Keeping track of requirements at different levels of the system and traceability between them can quickly become very complex. Various tools exist to aid management of requirements, both in textual form and visually in model-based systems engineering. When developing requirements, it is important to consider how they will be verified, and hence the system accepted into use. Verification evidence could come in various forms: lower-level requirements for which compliance has been demonstrated, checks or tests, certificates of compliance with specific standards or legislation, a quality management system for implementing the requirement, demonstrating that the system meets its top-level requirements and hence solves the problem it was supposed to solve, is known as validation. The V-model is a popular way of illustrating the different stages of requirements decomposition, verification, and validation. In summary, the first step in developing any product or service is to clarify the problem that we are trying to solve. Functional and non-functional requirements should be captured for all reasonably foreseeable uses and the system boundary defined. Different options for meeting requirements should be considered and a preferred option selected on the basis of cost, benefit, time, and risk. A system architecture should be developed for the preferred option and system-level requirements decomposed into lower-level requirements. Verification and validation demonstrate that requirements are satisfied using evidence such as lower-level requirements, checks, tests, and certification.